I am glad that James Webb Space Telescope is still working. I'm really looking forward to those images. And talking about the images, let's go to our final topic here. I was able to ask a question on the NASA Twitter Spaces for the James Webb Space Telescope team. They had a bunch of the team on to answer questions, to discuss what was going on with James Webb Space Telescope. And I asked a question about the data that we're getting from these telescope images. We have the Hubble images, and they were able to transfer that data back, and those images alone have kind of transformed how we all think of space. They're on all of our screen savers. Hubble has done some amazing things, and now with James Webb Space Telescope, there's so much data that we're getting from this. There's so much in just the alignment process that was needed, but also in the data that we're getting, and it's bigger. Like, there's a lot more data, which means the file's bigger. How are they getting it back to Earth? And all those different questions and how different it is. We were really lucky to ask a question, and then it spurred this moment with a bunch of other questions from folks asking online. I thought it was beautiful. I want to share that here. And of course, take a look for that NASA wave. By the NASA account when I asked my question, still blowing my mind. But we'll close out with that. Thank you for joining us on Today in Space. Have a great week, and we'll be back for another episode of Today in Space. Don't forget AG3D Printing for all your 3D printing needs, and help support the podcast, ag3dprinting.etsy.com. Follow us on Today in Space Pod, AG3D Printing on Instagram, Today in Space on TikTok. Have a great week, everybody.
So let's take a question from Philip, or PBS 713. If someone is given time to use Webb, do they get to control the telescope as well as the images and the data as they come in? Or are there engineers and other people who operate Webb and then give the images and data to the scientists who requested it? Oh, that's really interesting. Yeah, let's learn a little bit about these people who have proposed to look at different objects with Webb. Are they actually controlling the telescope? Maybe, Tim, do you want to take that one?
Sure. So when an astronomer knows what they want to observe, they put in a proposal, and it's actually a completely free process where a committee, the community in effect, chooses the proposals which are then selected and a telescope. And in that proposal process, the astronomer defines everything. So where the telescope will point, which instrument is used, the configuration of the instrument, so they can really fine-tune everything for the best science that they would like on the objects that they would like to see. So in effect, they are controlling the telescope, not physically in real time when we're looking at the objects, but they do define everything themselves during the proposal process.
Very cool. And actually, at this moment, I'm at the Space Telescope Science Institute in Baltimore, where actually there is a huge team of people literally controlling the telescope, people literally responsible for pushing buttons to send commands to the spacecraft. It was very cool to meet some of them earlier today. And if you stay tuned to our NASA Webb social accounts, you can learn more about mission operations next month. So let's see if we can get a live question in. Alex G. Orphanos, or ELGR3CO. Let's see. Can you unmute yourself and ask your question?
Hey, everybody. This is Alex from Today in Space. Thanks for getting my question. I was looking at, you guys have an amazing page with graphical animations of the process of dialing in the mirrors for James Webb, and it really got me thinking about how much data each image James Webb is taking. Is there anything that really you think that people should know about how different the data is each image that we're getting back is compared to something like Hubble, how far the technology has come? Thank you.
Thank you. That's a great question. Jillian, do you have thoughts on that?
Well, of course, one thing for Mary is that we have these super sensitive mid-infrared detectors, and they've never been on Hubble. So it's looking at the universe in an entirely different way with those detectors. Our detectors are quite small, though, because it's so much harder to make mid-infrared detectors, and we've only got 3 of them. So in some ways, our images will not cover as big an area as a Hubble image will, but they will be really unique because they're looking in the mid-infrared wavelengths.
Awesome. And Marcia, did you want to add anything about NIRCam and how its data is different from other telescopes?
Sure. And with the largest number of pixels on Webb and a larger number of pixels than any of the cameras on Hubble, I'm sometimes called the pixel pig. And if you use NearCam, it really takes all the bandwidth almost for sending data back to the ground. And so our data files are very large, partly because of the large number of pixels, partly because of the way we take the data, which has been used on the infrared camera on Hubble, which is much smaller, but we save all the readouts. And so if we expose for 1,000 seconds, we might send 10 different images to the ground for that 1,000 seconds, each one of which is separated by 100 seconds from the previous. And we do it at 2 wavelengths. And so this totes up to a lot of data coming down at once. But the archive has already demonstrated that it can ingest this and make it available, at least right now, to those of us that have to analyze the test images.
Very cool. Well, let's see if we can get another live question. This is from Mux Harris. I think you're able to unmute yourself. Mux Harris, are you able to unmute yourself?
Hey, this is Haris from Pakistan. I have a basic question. Will we be colorizing the Webb images like we used to do Martian images? Is it even possible with infrared cameras?
Thank you so much. That's a great question about how the images will look. Will they be sort of artificially or naturally colored? Let's see. I think I'll go to Renee first.
Yeah, well, it's a very good question. So when we get our images, there's a lot of artifacts that we need to correct. So there's a lot of image processing that has to go on. So these force science centers are really complex machines. But what is not fully appreciated sometimes is that the data processing of these images and data are actually quite a lot of work. So the images you're going to see early July, which will be extremely beautiful, are a lot more beautiful than the raw image that we're going to have. But it's part of the process that we need to process these images. And I just want to come back to a point of the previous question about the data flow, which it's this huge amount of data that we have to transfer from the 1.5 million kilometers. Just to give you an idea of the data flow, it's like the data rate is similar to an LTE network. So Webb is equivalent to have an LTE network at 1.5 million kilometers away. So it's not bad.
Wow, LTE service at 1 million miles away. That is very powerful. Marcia, would you like to add something?
Yeah, since our eyes aren't sensitive to the infrared, if we make an image to show what we found, we have to inject some color interpretation. And if you think of the images and spectra that come from Webb, they're like a digital camera image, but we get to assign somewhat arbitrarily who's red, who's green, who's blue, and so on. And sometimes we do that to highlight a particular feature in the image. And so we'll see how these, what should properly be called false color images, because our eyes can't see the infrared.
Thank you. Yeah, so these images will look spectacular. Webb is really our infrared eyes on the universe, since our eyes cannot process these images. That's why we have this amazing telescope to do so. And rest assured, there will be some coloration, but it will be applied kind of after the fact to highlight certain features. So let's go to a question from Twitter from Ty. Will you be observing the TRAPPIST-1 system? And if so, what will Webb be able to tell you about the planets that previous telescopes could not? I'm going to start with Jillian. Would you like to talk about the TRAPPIST-1 exoplanets?
Well, we will be looking at one of the TRAPPIST exoplanets, TRAPPIST-1b, and our interest is to look at the atmosphere or try and detect features coming from it with the spectroscopy, so that we can look at maybe what kinds of things are in there. But Rene is much more of an exoplanets expert than I am, so I think we should ask him.
Well, the TRAPPIST-1 system is the rock star of exoplanet, right? This is the TRAPPIST-1 is a very small star. It's not much bigger than Jupiter in our known solar system, and there's 7 planets that goes around this star, and they happens from our perspective to transit. So the every 7 planet goes in front of the star, and they're just blinking at us. And so what we want to do with Webb is answer so all these planets have about the same size and mass as the Earth. And we think that 3 of them are in the so-called habitable zone. So not too close, not too far from the star, so that we can hope to have maybe liquid water at the surface of these planets. So, but what we don't know about these planets, what are they made of? Do they have an atmosphere? Do they have water? Maybe some of these planets are water worlds, rocky core covered by oceans. And that is the big questions that Webb will try to answer. Do these planets have an atmosphere? In fact, all science instruments will look at these planets very eagerly. And in fact, the very first data that will come from Webb on transiting planet will actually TRAPPIST-1. By mid-July, we'll have quite a lot of data on the TRAPPIST-1 system with NearSpec and the nearest instrument, and later on with MIRI. So it's very exciting. So very early on, we'll have data from the TRAPPIST-1 system.